Good afternoon, students. Myself Sushmita, Assistant Professor, EC Department, RCET. So, in this session, we will be learning about Impatt Diode. So, first, let me tell you a small introduction of what Impatt Diode is. After, in the upcoming session, we will see in detail about each and everything. So first thing, diode is this particular PN junction diode is reverse biased. When it is reverse biased, the current flow will not be there. So in order, when the reverse voltage exceeds a certain voltage, we can say that there will be a breakdown in the junction and the current will flow only slight when it is increased in voltage. So this particular breakdown is called as avalanche multiplication of electrons and holes in the space charge region of the junction. Similarly, PN junction is an avalanche breakdown condition. It will be exhibiting negative resistance characteristics in the microwave frequency range. So since there are negative resistance that is based upon avalanche multiplication as well as transit time effect of carriers, this device has been also called as Impatt diode, that is impact avalanche transit time diode. So coming to the device structure, the original suggestions for a microwave device which is implied by time transit effect, which was initially made by W.T. Reed, and it is involving an N plus minus P IP P plus structure, that is which is shown in the figure you can see in the PPT. So how this device operates is that we will be injecting carriers along the drift region, and this particular operation is called as Impatt diode. So mainly it will be consisting of two region, that is N plus P region at which avalanche multiplication occurs, and another one is I. We can call it as essentially intrinsic region. So along this we can say there are generator holes which must drift in moving when it is coming in contact with P plus. So this is the two essential regions of Impatt diode. So you can see cathode and anode, we will be having P plus and N substrate. Similarly, along the drift region it will be N minus, that is holes, and then again in the right hand side we will be having the N plus. So when we do the doping, the region of drift will be getting decreased. So what is doping? Doping is nothing but we will be adding some amount of impurities to the pure material so that the concentration become increased. So that particular process is called as doping, that is addition of impure materials. So coming to the principle of operation, so in Impatt diode it will be having extremely high voltage gradient when we are giving a supply of about 400 kilovolt 12 centimeter, and it will be acting as a normal one when the PN junction cannot withstand. So coming to the high potential gradient, back biasing of the diode can cause a flow of minority charge carrier across the junction. So this particular AC current is approximately said to be 180 degree out of phase with the applied voltage, which will again give rise to the negative conduction as well as oscillation in the resonance circuit. So next one is VA characteristics. As you can see along the voltage and current characteristics, when there is an increase in voltage and there will be a increase in the current, you can see clearly from the diagram. So coming to the construction, Impatt diode is particularly made up of silicon. So as silicon is cheaper and easier, it is used to fabricate along the epitaxial growth. So you can see in the below figure it is showing a typical Impatt diode. The gold alloy contact is used at it as it is having a low ohmic as well as the thermal resistance. Coming to the classification, so as I told you in the previous slide what is doping. So depending upon the material that we are going to add, depending upon the impure material that we are going to add to the device structure, these particular Impatt diodes are classified into three basic types. So first one is single drift region. So single drift region is nothing but it will be consisting of single avalanche zone as well as a single drift zone plus P plus N plus plus structure. Similarly, double drift region, that is DDR. DDR is nothing but it will be having a P plus PNN plus structure. So it will be again having two drift layers. So one which will be consisting of electrons and another one which will be having holes on the avalanche side, either sides of avalanche zone, that is central avalanche zones, either side, with both sides we will be having this thing. And third one is DAR, that is double avalanche region. So this double avalanche region diode has P plus NiPn plus structure. So it will be consisting of one drift zone sandwiched between two avalanche zones. The electrons and the holes from two junctions will travel across the central I region but in the opposite direction, and it will be delivering the power. So listing of the disadvantages of using Impatt diode. So it will be having a noisy, because since it is a noisy process. And second thing is noise figure will be up to 30 dB, so which is not good for klystron or either gun diode or traveling wave tube amplifier. In that case we cannot go for using the Impatt diode since it is producing more amount of noise. Third point is tuning range is not good as in gun diode, whereas in gun diode we can go for tuning the range and we can go for using it in amplification, but in this case we cannot go for tuning as we are doing it in gun diode. That is another one drawback of using this Impatt diode. So coming to the application, this diode, it will be making excellent microwave generator for applications like parametric amplifier, parametric up amplifier, parametric down converter, negative resistance parametric amplifier. These are various applications of using microwave generators. So I hope you all understood and had an useful session. If you have any doubts, you can do comment in the comment section. Thanks for watching this video. Thank you.